After we explain, then look at the notes.
Okay. All right. So here I am recording this. Okay. So you kids need to know what is oxidation and reduction. All right. For oxidation reduction, remember you can write this on a notebook paper or what is going on? It's going on the line. It's not aligned, right? Okay. This page is really bad, right? So I got a hard copy from this picture.
Yeah.
Okay, so the concept of oxidation reduction is very old. So people started using metals a number of years ago. Is that right? We found metals under the earth. We purified them. We made it a single metal. We had iron. We had copper. And then when we had things made of iron, they got rusted. All right? Or when we explored it further, we said, oh, the metal is getting oxidized. We realize that it's reacting with the oxygen in the air. That's the term oxidized. All right. So if you have iron and it's combining with the oxygen in the air, all right, it can make Fe2O3. That's kind of a formula for rust, which is more complex. All right. So it has iron. What do we say? Iron has been oxidized. So for us, oxidation means there has to be oxygen to react with iron. Is that right? But that is no longer true. You don't have to have oxidation, and the definition has moved away from just wanting to have oxygen. So what does oxidation mean? So we're going to learn a mnemonic that says, Leo the lion goes grr. Leo the lion goes grr. And what does it stand for? Those of you who watch the videos will know this. All right? Loss of electron is oxidation. And gain of electron is reduction. Are we good? All right? Kind of when iron is getting oxidized, what is it doing? It's losing some of its electrons to oxygen. Oxygen is gaining those electrons. Remember, loss of electrons and gain of electrons have to happen simultaneously. It cannot happen in isolation. Law of conservation of mass dictates that matter is not lost. Is that right? So one cannot lose an electron, it can disappear into space. Does that make sense? Okay? So they take place together. Iron is losing its electron, oxygen is taking the electron, and together they're forming a product. Iron has been oxidized. Oxygen has been reduced. Does that make sense? Oxidation, reduction together is called redox. Reduction, oxidation, they're called redox reactions. Does that make sense? Okay. Now, in order to find out, so now here is another example of oxidation reduction, all right? So in this case, you had oxygen. So you take Na plus Cl2, giving NaCl. You're making table salt with sodium and chlorine gas. Are you with me? Does it involve oxygen at all? No, it doesn't involve oxygen at all. But yet, this is an oxidation reduction reaction. And in this case, sodium is oxidized, chlorine is reduced. So how do you determine which is the element that has been oxidized, which is the element that has been reduced? Yes, Natalie. You wanted to say something. Well, what do you want to share? I would like to hear what you have to say. So here now he's saying sodium is getting reduced, chlorine is getting oxidized. But she really doesn't know how to determine that. Is that right? And so she's making a guess. Is that right? So what we're going to do in today's class is we're going to find out how to say which element is oxidized, which element is reduced if we are provided with a redox reaction. Does that make sense? So in order to find out that, the first thing you have to know is how to determine what we call an oxidation number for an element. All right? So what is oxidation number? Remember we did charges before? Is that right? Did we say metals in general like to lose electrons? Non-metals like to gain electrons? Do you remember that? We ended up calling metals losers. We said this was a +1, a +2, a +3, plus -4, -3, -2, -1, and 0. Even though we had these charges listed for the elements, it's not true in every single case. Depending on what the element is combined with. Does that make sense? Sometimes they lose, sometimes they gain. For instance, if you look at nitrogen, you would think every time it wants 3 electrons. Is that right? But then nitrogen can combine with oxygen, where oxygen wants the electrons. It's not going to give it to nitrogen. All right? It's more powerful in pulling the electron towards itself. Well, in that case, nitrogen doesn't take the electron. It ends up giving electrons. So in that case, the charge on nitrogen is no longer -3. Now it has an oxidation number. Does that make sense? And how do you determine that? So there are a set of ground rules for how do you determine oxidation number. My kids have to know this. All right? You have to know it from the top of your head. This will not be provided to you. Are we good? Let's go through these rules. They're pretty basic, self-intuitive if you understand them. There isn't a lot of memorization. All right? Let's go through them. If it is an element by itself, are you with me? Then it's always, what is it? It's by itself. It's not giving or taking. Is that right? What is its oxidation number going to be? 0. When it's by itself, it's neither giving nor taking. Does that make sense? So it's always going to be 0. For a monoatomic ion, it's the charge on the ion. All right? Supposing I say chlorine is a -1. What is the oxidation number of chlorine? -1. If I say nitrogen is -3, its oxidation number is -3. If I just write a single atom and write a charge on top of it, that is its oxidation number. Or if I write Na+, what that means is this has gained electrons, 1 electron, this has gained 3 electrons, this has lost 1 electron. Remember, electrons are negative. When you lose an electron, you become positive. Remember this. If you lose electrons, which is negative, what does the element become? Positive. When the element gains electrons, which are negative, what do you become? Negative. The more you gain, the more negative you become. The more you lose, the more positive you become. Are we good? Okay. So this is another ground rule. Alkali metals are always +1. In any compound, you see an alkali metal, how many electrons will it lose? 1. If it's an alkaline earth metal, how many electrons will it always lose? 2. It will be a +2. Fluorine, they don't talk about all the halogens, they only talk about fluorines. Whenever it's fluorine, how many will it gain? 1. Doesn't matter which compound. Fluorine does love electrons. It will always take it. It's the most powerful element in the periodic table that will just grab what? From anywhere, any element around it. Is that understood? Fluorine is always -1. They didn't talk about chlorine, bromine, and all those things. Remember that. All right? Oxygen is always the next one to consider is oxygen, which is an element in abundance around us. Is that right? Oxygen is always seeking for 2 electrons. Oxygen will be mostly -2, except in peroxides where it is a -1. Hydrogen, it's in this side of the periodic table, is always a +1 except a metal hydride. So you combine a metal with hydrogen, it's going to be -1. But otherwise, hydrogen is always taking. Hydrogen is always giving. It's a +1. Only with a metal hydride it is taking in. If it is a compound, the sum of all oxidation numbers is always a 0. And if it's a polyatomic ion, it's the charge on the ion. Let's translate this to examples. The rules in and of itself mean nothing to us. So you may want to use a notebook paper and find out how do we solve for oxidation numbers. Let's look at the first example. It's just K. What will be its oxidation number? 0. Okay? It's equal to 0. The next one is rubidium chloride. So I'm going to do this in the bottom. Alright? The next one is rubidium chloride. If you take the example of rubidium chloride, remember you have to use the rules. Alright? The rule only says we know that for rubidium. Is that right? What is the oxidation number on rubidium? It's always +1. Rubidium will always give away its 1 electron. So it's 1. We don't know what it is on chlorine. Let's say that's X. Right? But what is the sum of the oxidation numbers for a compound? It's always going to be 0. So chlorine in this case, when we solve the equation, what does it turn out to be? -1. So therefore the oxidation number of chlorine is -1. Alright, rubidium is a +1, chlorine is a -1. Do you understand this? Alright, let's go up. Let me not go up, and let's see. What is the next example? Can we do the next one? Na2O, sodium oxide. Alright? How do we, well, in this case, both of them are given as rules. Is that right? So, sodium is going to be a +1 and oxygen is going to be a -2. Will I say sodium is a +2? No, because there are 2 sodium atoms that are +1 each. Correct? And that is cancelled by the -2 on oxygen, which becomes 0. Does that make sense? Do you understand how this is 0 in this case? Alright, let's go to 3, and I made a mistake with my other class doing this. Alright, and I'm better off now. So, in this case, what is the one we know? Hydrogen. And what will you assume hydrogen to be? +1. Alright, because it's not attached to a metal. So nitrogen is X plus 3 times +1. Correct? Hydrogen is a +1. Oxidation number is a 0. Or in other words, X plus 3 is 0. Or what is the oxidation number on nitrogen in this case? -3. Are we good? Alright, let's do, yeah.
Go back to
Which one?
the last one that we did.
Okay, here we are.
That one, the next one.
This one?
Yeah, that one. Na2.
Yeah, this is, well, both of them are listed in the rules. Right, Ricky? Sodium is a +1. But how many sodium atoms do we have? So that makes it a +2. And that's why it becomes a 0. Are we good? Okay.
Wait, Ms.Geeta,
Yeah?
would NH3, would the H, like the thing for hydrogen, also be +1?
Hydrogen will be a +1. Last class I made a mistake of taking it to be a -1. I said it's a hydride. It's not. Alright? It's not with a metal. And I thought it depends on the electronegativity value. I got a little confused there. But it's a +1. Alright? Anyway. Guys. Which one should I do next? Can we do number 6? Alright? Number 6. How do I approach it? It's N2O5. What do we know from the rules? Which one do we know? Oxygen. So oxygen, there are 5 atoms of, there are 2 of nitrogen. Do we know for what it is for nitrogen? No. So we assume it's 2x plus, there are 5 atoms of oxygen. What is each atom of oxygen? -2. And what does a compound add up to become? 0. So how will you expand this equation? 2x minus 10 equals 0. What is x? 5. Positive 5. Hey, we thought nitrogen was a -3. And in this compound, nitrogen actually ends up losing 5 electrons. It's a positive 5 oxidation number. Does that make sense? Can we do which one? Okay, we'll do number 14. All right? It's a peroxide. H2O2. Right? It's a peroxide. So in this case, we will not assume that we know it for oxygen. We know it for hydrogen. So hydrogen is 2 times plus 1 plus, all right? We don't know what it is for oxygen, equals what? 0. Is that right? So it's 2 plus 2x equals 0. What is x? What is x? -1. So oxygen in its peroxide is the -1. Yes, Claudia?
Can you do number 9?
Number 9. Okay, we'll do number 9. It's a polyatomic ion. All right? CaCO3. All right? Yes.
So for number 14, would oxygen be considered a peroxide?
It's a peroxide.
So oxygen,
Because otherwise it's always taken to be a -2.
right. If it was like a single oxygen atom, like without the 2, then it would just be.
It would be an oxide. It would be a -2.
Okay. And if it's O3, then it's not a peroxide.
It's not a peroxide anymore.
All right. Cool.
Yes, Mohir. For 14, all right? For 14, yes. What is the actual? X is -1. For oxygen, it's a -1. Yeah, but yeah. If you know it, you can just state it. But even if we solve it, we still arrive at the same answer. Okay? So we are doing number 9. All right? So there are 2 ways to do this problem. Okay? You can do it in 2 different ways. We know calcium is an alkali earth metal. Right? Is it in group 2? So calcium will always be a +2. Correct? Do you recognize this as a polyatomic ion carbonate? Do you recognize that? So for the compound to be neutral, the carbonate has to be a -2. Otherwise it can be a 0. Is that right? But then carbonate itself is made of carbon and oxygen. So what is the oxidation number on carbon? What is it on oxygen? So we can say CO3 is a -2 together. Is that right? In CO3, what do we know? Oxygen. There are 3 oxygens, each one is a -2. There is 1 carbon which we don't know. What does that equate to? -2. So x -6 equals -2. What is x? +4. So in this particular compound, calcium's oxidation number is a +2. Carbon's oxidation number is a +4, and oxygen's oxidation number is a -2. Do we get this?
When you write the oxidation numbers, you just write that, like you say Ca equals this.
Yeah, you can finally arrive at the oxidation number for each and every element in the given compound. What does the question say? To each element in the following. Let's do one more example. I'm going to do 11 and then I'm going to move on and you can practice the remaining at home. Is that all right? I'm doing number 11. It's sodium dichromate, right? 11. Na2Cr2O7. Say you don't know what a dichromate is. Can you figure it out? Right? So, what is it on sodium? +1. But how many sodium atoms do you have? 2. So, this is 2 times +1. That's a +2. What should dichromate be then? -2. Is that right? So, let's say the dichromate CrO7 is a -2. What can we solve for? We don't know what it is on chromium. Is that right? Do we know what it is on oxygen? Equals what? -2. -14, 2x -14 equals -2. What is x? +6. Right? So sodium is a +1, chromium is a +6, oxygen is a -2. Do we understand this? Okay. So we are going to move on. The goal for us is to find out in a given reaction what is oxidized and what is reduced. Determining of oxidation number itself is not the final goal. Is that right? So let's go back and look at the first example that we had. Iron is combining with oxygen to form iron 3 oxide. Okay? So let's assign oxidation numbers. What is the oxidation number for iron in this reaction? It is an element. What will you say is the oxidation number for iron when it's an element? 0. What is the oxidation number for oxygen? Remember, is it combined with anything? It's an element. So what is its oxidation number? 0. Okay? So let's look at this compound. Do we know to determine the oxidation number for iron and oxygen in a compound? Did we just do that? Okay? So what do we know? It has 3 oxygens, correct? 3 oxygen, each one is a -2, correct? And plus, we don't know what it is for iron, should be equal to what? 0. So what is x? 2x minus 6 equals 0. What is x? X equals +3. Right? And oxygen is the -2. So we arrive at the fact that this is a +3 and that is a -2. Correct? Do we all understand this? Okay. Remember, when I lose electrons, I become, when I gain electrons, I become negative. Iron was 0. Iron has become +3. Is iron oxidized or is iron reduced? What do you conclude? Yes. When I lose electrons, I become positive. When I gain electrons, I become negative. Iron was 0. What is iron now? +3. Have I lost or have I gained in order to become +3? I have lost. Remember, Leo the lion goes grr. Don't forget that. Leo the lion goes grr. All right. Loss of electron is oxidation. Alright? Gain of electron is reduction. Don't forget this. So did iron, narrowly going back, iron has become positive 3. Did it lose or did it gain? It lost. If it's lost, has it been oxidized or has it been reduced? It has been oxidized. Do you understand this? Iron is the element, so we can say iron has become Fe plus 3. How did it become plus 3? It is on the product side. If I write electrons on the product side, it means I have lost my electrons. Does that make sense? Iron has gone from being 0 to a plus 3. Iron has been oxidized. Alright? So electron on product side means what? It's lost. Iron has lost 3 electrons and has been oxidized. Alright? This is called the oxidation half reaction. What is this called? It's called the oxidation half reaction. What has happened to oxygen? Let's go up and check on oxygen. What did oxygen do? It went from being a 0 to a minus 2. Did it gain electrons? Only then it can become negative. So, if has oxygen been reduced? So, if I'm going to write the reduction half reaction, I'm going to write the reduction half reaction. What am I going to say? Well, each oxygen needs 2 electrons. Is that right? O becoming O minus 2 needs 2 electrons. Is that right? But this is written as O2. So how many total electrons do you think it will require? 4. Each atom of oxygen will require 2 each. So this plus 4 electrons becomes 2O minus 2. Where have I written the electrons? On the reactant side. Alright? Electrons on reactant. It's not lined again. Jacob, I did that in the other class. It made 0 difference. I'm telling you, I'm serious. Kids told me. No, I took you what you said very seriously. You told this to me once before, and we tried it. I think I don't know what's wrong with this. It's maybe the way I write. Electrons on reactant side is what? Is gain of electrons. All right? Are you understanding the half reactions? Are you understanding what I just did? Okay? So you will be asked to do this. You will be given an equation. What you have to do is determine the oxidation numbers. Once you determine the oxidation numbers, you will be asked, okay, now tell me which element got oxidized. Tell me which element got reduced. Can you write down the half reactions for the oxidation and the reduction? Do you understand? This is what you're expected to know as far as oxidation reduction goes. There's one more aspect of this that you have to know. Now, so remember, what did we say? Iron got oxidized. Remember, oxidation reduction always happen at the same time. Is that right? One is losing, one is gaining. It cannot happen in isolation. Iron is oxidized. By itself getting oxidized, it is acting as a reducing agent because it's helping oxygen get reduced. Yes or no? Iron is oxidized, but it is a reducing agent. What is an agent? Somebody that facilitates that process. By losing, by giving away its electrons, what is iron facilitating? Reduction of oxygen. Oxygen, on the other hand, is getting reduced. Yes or no? By taking in the electrons, what is oxygen doing? It's acting as an oxidizing agent. Does that make sense? Oxygen is an oxidizing agent. There's one more vocabulary word that you have to know. Are we good? Shall we do the second example? Well, we said we don't always need to have oxygen for an oxidation reduction reaction. Is that right? That was how the concept originally came about. But here we have a reaction. As we understand chemistry better, it is becoming salt. Let's write out what are the elements' oxidation numbers. All right? What is the oxidation number on sodium? 0. What is the oxidation number on chlorine? 0. In this compound, applying the rules, what oxidation number do you know? For which element do you know this? Sodium is a +1. If sodium is a +1, what should chlorine be? -1. Natalie, I'm going to come back to you because we saw that confusion that Natalie had as to which element was getting oxidized, which element was getting reduced. Right? What do you think is happening to sodium? Is it getting oxidized or is it getting reduced? Very good. Sodium is getting oxidized. What is happening to chlorine? Chlorine is getting reduced. So we know sodium is oxidized. We know chlorine is reduced. Now are we able to decide which is the element getting oxidized, which is the element getting reduced? Let's write the half reactions. All right? How do we write the oxidation half reaction? So we have sodium. What is sodium becoming? Na plus an electron. Right? It's lost the electron. It's been oxidized. If we were to write the reduction half reaction, all right? So it's chlorines, it's Cl2. Each chlorine requires 1 electron. So 2 chlorines will require 2 electrons, which will become 2Cl minus. Well, it's enough if you're able to recognize which element is getting oxidized and which element is getting reduced. But it may annoy some kids that it's not getting balanced, right? Balancing of redox reactions can be tricky at times, but these are really simple examples. So we can try and balance them if you want. So let's go to this reaction at the top. This equation is not balanced, right? If you balance, you should have 2 sodium giving 2 sodium chloride. Are we correct? Yes? Do you agree? Is this the balanced equation? Or in other words, when I write my oxidation half reactions, 2 sodium become 2Na++, 2 electrons. Does that make sense? So sodium gives 2 electrons, chlorine is able to accept. There is no, the number of electrons exchanged have to be equal. Does that make sense? And therefore now you have the balanced equation. Do you understand that? Okay, I'm going to do one more example and then we're going to move on, all right? The example that I'm going to do is this one. Methane plus oxygen giving carbon dioxide plus water. What is the type of reaction here, guys? Combustion. Okay? Let's do methane plus oxygen giving carbon dioxide plus water. All right? Methane plus oxygen giving carbon dioxide plus water. The first one itself is a compound. I have to determine the oxidation number for carbon and hydrogen. What do I know from my rules? Hydrogen. What is hydrogen's oxidation number in this case? +1. So that's going to be 4 times +1, which is a +4. What do you think is carbon? -4. So carbon is a -4. What is the oxidation number for oxygen on the reaction side? 0. Good? Okay? So what is for carbon dioxide? Which one do you know? Oxygen. And how many oxygen atoms are there? 2. So what will that become? Oxygen is a -4. Is that right? Or in other words, it's 2 times -2. Is that right? So what does carbon become then? +4. Carbon becomes a +4. Let's look at water. If you look at water, well, we kind of know both of them. Is that right? What is oxygen? -2. Is that right? And hydrogen, each one is a +1. So it's 2 times +1. Is that right? Are we good? So who would like to volunteer and tell me which element is getting oxidized, which element is getting reduced in this reaction? Yes, Ricky.
CO2.
Uh-huh. -2, which one? The
CO2 multiplied by -2. No, right there, CO2. Negative +4.
CH4, you mean?
No, CO2.
Okay. Why can't I write Cl2 like
No,
this?
CO.
This one? Okay, CO2. How many oxygen atoms are there?
2.
Each oxygen is how much?
-2.
So I get a -4, right? And then that balances with a +4. If I were to do it on the side, Ricky, as a problem, if I tell you, okay, for carbon dioxide, determine the oxidation number for each element in this compound, how would you solve the problem? You would say, I don't know what it is for carbon, plus, you know there are 2 oxygen atoms, each one is a -2, and you would say that equals 0. Or you would say x -4 equals 0 or x equals +4. Are you with me? Okay. I want to know which element is oxidized, which element is reduced in this given equation. I need a student volunteer. Okay? One of it should jump out, so you should be able to figure out the other one. Which is getting oxidized, which is getting reduced? Yes, Claudia. All right, so we know the reduction half reaction. Good. So the reduction half reaction, what is the reduction half reaction? Claudia, help me. What is the reduction half reaction? O2 will gain 4 electrons total. Each oxygen will need 2. Is that right? And you say gain of electrons giving you 2O minus 2. Is that right? What is the oxidation half reaction? Which element is getting oxidized? Oxidation half reaction. What is that? So what is carbon? From where to where? Very good. So carbon was a -4. What is it going to? A +4. A negative element is becoming neutral and then becoming positive. How many electrons do you think carbon lost? 8. Is that right? Did it lose 8 electrons in the process? Is it making sense? From -4 to 0, it lost 4, and then it lost 4 more to become a +4. Correct? Well, the equation is not balanced. Kind of the electrons are not balanced. Is that right? Yes.
balance their equation on
Well, for beginning, it's enough if you identify the oxidation and reduction half reaction, because these are easy equations that without additional help you can just balance them and you will be able to balance the electrons. But there is more to this than meets the eye. There can be some that are really difficult, and there are special rules in how you balance a redox reaction. So for now, I'll say if you can recognize the oxidation and reduction half reactions, that will be helpful. That should gain you all the points you require. But it bothers some kids that it's not balanced. All right? So we can balance it. It's not that hard. Let's balance the equation. So how do you think you can balance this equation? Can somebody give me the balanced equation? Because we can go backwards in this. We can actually balance and then figure out the half reactions. The proper way to do it is actually to look at the half reactions and then balance the equation. I know the equation is not balanced because the electrons do not tally. Is that right? So which side needs to get multiplied to up its number? The oxygen side. Yes or no? The oxygen side needs to be up by how much? 2. Right? So, right? The oxygen needs to be up by 2. Let's go up. And let's try putting in a 2 here. Is the equation balanced? Okay, in front, because that doesn't give me the number of oxygen atoms. 2, 4, 2 plus 2, 4. Does that make sense? So I now accounted for all my oxygen atoms. I looked at the half reactions. I knew my equation was not balanced. Or in other words, what I did was I put a 2 here, right? That makes it how many oxygen atoms? 4. Each one needing will be how many electrons? 8. And now my equations are balanced. But it's okay if you just recognize the half reactions. Does that make sense?
you should balance it before you do all the
No. That's what I'm saying, Claudia. Oxidation reduction is not that easy.
Okay.
We are going backwards, but actually you should go forward. You should be able to write the half reactions and then balance the equation. All right? Because we are doing such easy examples, we can do it.
Hello.
So are we good with redox? All right? Guys, remember, next class I think I'm going to give you a quiz on this. All right? I'm going to stop my recording right now. So let's do that.